a prestigious organization of India that has produced many proud moments for the nation and raising the bar with each achievement is the Indian Space Research Organization, ISRO. ISRO established itself as an operational space system provider to the nation through the successful launches of pslv and GSLV. While pslv and GSLV have 2-ton capacity in geosynchronous transfer orbit and have prodigious hoisting of continuous successful flights, India's immediate and future satellite requirements need 4-ton capability. India's dependence on foreign launchers for launching heavier communication satellites is still a big challenge to overcome. As the communication satellite requirement presenting GSLV Mk III, the next generation launch vehicle. GSLV Mk III, also known as LV-M3, is the heaviest and most powerful launch vehicle ever developed in the history of Indian space research. Standing as high as a 14-storied building, the vehicle is 43.43 meters in height and 4 meters in diameter. GSLV Mk III will have a payload capacity of 4 tons for geosynchronous transfer orbit GTO and will be able to place a 10-ton satellite in low Earth orbit LEO. LV-M3 is a 3-stage vehicle comprising of 2 identical S200 motors as first stage, L110 liquid stage as second, and a cryogenic upper stage C25 as the third stage. GSLV Mk III carries a larger version of India's cryogenic upper stage powered by indigenously built cryogenic engine. Designed to be flexible, scalable and evolvable to meet a variety of cargo and crew mission requirements, GSLV Mk III is the answer for the nation's long-standing ambition to send humans into space. LV-M3 can cater up to 6 tons to GTO with minimal design modifications and a few changes in propulsion modules. A suborbital experimental mission known as LV-M3X mission was conducted to test the vehicle performance during the critical atmospheric phase of its flight. On December 18, 2014, the final hour approached at 9:30 a.m. Indian Standard Time. India's very first heavy lift launch vehicle GSLV Mk III lifted off majestically. The 19-minute flight carried an alternate payload to an altitude of 126 kilometers before payload re-entered the atmosphere at a speed of 5.3 kilometers per second ahead of a parachute-assisted splashdown in the sea.
India, you have the new launch vehicle with you. We have made it again. The powerful launch vehicle has come to shape, which will change our destiny in placing heavier spacecraft into communication orbits.
Every PSLV and the subsequent GSLV takes you to higher and higher heights, not only physically but also mentally and from performance wise. So the GSLV Mk III, I am sure that is very much closer to the goal that we have set for it.
Raised to the occasion to meet the national demand of launching 4-ton satellite from our own soil. The day is not too far, maybe another 2 years we will again meet in the same place to launch 4-ton satellite in geostationary transfer orbit.
After the post-flight analysis of GSLV Mk IIIX mission, ISRO made configuration changes in the vehicle for ensuring better performance. heat shield shape changed from conical to ogive, and S200 strap-on motors have been changed to slanted shape. In addition, grain configuration of head-end segment of S200 motor has been modified to reduce the peak dynamic pressure on the launch vehicle during atmospheric flight regime. The cryo engine development got the full momentum after the X mission. Within 2 years, ISRO completed all major tests of cryo engine without a single failure. India is the only country that achieved the cryo engine technology within such a short period. Perhaps the C-25 stage development is the best thing that happened from ISRO during the last 15 years. Today, a fully tested and qualified C-25 engine is ready with ISRO to fly with GSLV Mk III vehicle. With proven S200 and L110 stages and fully tested and qualified C-25 upper stage, now ISRO is confident in going for the historical launch of GSLV Mk III D1 flight.
Seven, 6, 5, 4, 3, 2, 1, 0, plus 1,
Vehicle lifts
plus
off.
2, plus 4, plus 5, plus
S200 is the third largest solid booster in the world, providing high initial thrust to 640-ton vehicle to lift off. Each S200 is filled with 205 tons of solid propellant and is cast in pair to achieve similar characteristics. It ensures smooth liftoff and imparts required escape velocity to the vehicle. The aerodynamics of GSLV Mk III are more critical as the strap-on boosters are only in single plane. The absence of strap-ons on the other plane makes the pitching and yaw maneuvering slightly difficult. During this phase, vehicle passes through the transonic region and is the most critical phase of the flight. The second stage is called L110 stage and is powered by already proved twin Vikas engines and propelled by earth-storable propellants. The stage ignition is controlled by the vehicle acceleration and scheduled at 114 seconds into the flight. The clustered Vikas engines are working on a common control system in tandem with S200 control available at the same time. The vehicle experiences maximum load due to dynamic pressure, combined stage thrust and inertial load. In this period, the vehicle also experiences enormous heating in the base region due to the combined burning of the stages and the reverse flow generated. The S200 burnout is more shallow in nature and separation is initiated based on the vehicle acceleration at about 140 seconds into flight. The S200 separation is pitched down, aided by 12 jettisoning motors which are used first time by ISRO for the purpose. After S200 separation, the vehicle is powered by L110 alone. The L110 plume is yellow in color and long. It helps the vehicle to clear the atmosphere and to reach almost the perigee altitude. By this time, vehicle clears the atmospheric region and the presence of payload fairing becomes not essential and hence separated at 224 seconds at an altitude of 115 kilometers from Earth. The composite payload fairing is the largest ever made by India and has a volume of approximately 100 meter cube. The L110 stage shutoff occurs at 168 kilometer altitude and is done by onboard command. The C-25 stage nozzle is extending almost 4 meters into the L110 structure. The safe pull-out of the separated stage is aided by firing of 4 separation motors fixed on the spent L110 stage. C-25 stage ignition will happen after 3 seconds of L110 stage shutoff. The high specific impulse generated by the gas-generated cycle of the cryogenic engine works for almost 643 seconds. This duration in the flight's long journey helps in providing sufficient orbital velocity to the payload. The plume of C-25 stage is flared, dome-shaped in nature and colorless. An indigenously developed, fully qualified, active C-25 stage is first time flying in the GSLV Mk III D1 mission. The cryogenic stage shutoff is based on attaining the required velocity for satellite and is separated using Merman band separation system. The C-25 stage helps in delivering the 4-ton payload into the geosynchronous transfer orbit with the required orbital velocity of 10.25 km per second. The C-25 stage and the satellite are moving in space with almost the same velocities. The chances of the spent C-25 stage hitting on the satellite is avoided by properly maneuvering the C-25 stage with the help of reaction control system on the stage. The orbit raising of the satellite is done by firing liquid apogee motor. It will take approximately 3 rotations around the Earth for the satellite to raise the required orbit. During this orbit raising process, the onboard power requirements are completely met by specifically developed lithium-ion batteries. The solar panels and onboard antennas are deployed at the geosynchronous orbit. The Indian space program today is a combination of vision, commitment, enthusiasm, hard work and innovation, with each aspect becoming instrumental in driving the growth and stability that we all aspire to achieve. As the nation is surging ahead into the new frontiers of space, GSLV Mk III is rocketing us ahead of time and providing the required thrust to the nation in every aspect of progress and prosperity. LV Mk III is going to be a real game changer for ISRO.